equivalent stiffness. Equivalent stiffness. Last session we discussed the equivalent stiffness and we took two cases in which we have two springs K1 and K2, they are in parallel. So the equivalent spring here, it will be K1 plus K2. And also we considered another case in which the springs are in parallel, K1, K2. And we learned that 1 over K equivalent equals 1 over K1 plus 1 over K2. Today we will go through more complicated example, more difficult example, and try to solve it. For this system, you see, we have this system, we have two stiffnesses. So this is determine the equivalent spring stiffness for this system and natural frequency of vibration. Neglect the mass of the beam. And this one, the beam. So now here it is a mass. The weight, this is the weight, is W. So M equals what? Equals W over G, where G is the gravitational constant. Now here I have this stiffness and the beam stiffness, they are in parallel. So I have, it is like this. So this one is for the spring and this one is for the beam. We learned last session, that K beam, it is from the tables. We highlighted this one and we gave one example or two about this one. K beam equals 3EI over L cube. That means the equivalent spring equals K plus 3EI over L cube. If you simplify, this one will be K L cube plus 3EI. So this one is the answer for the equivalent spring constant. Now, the second one, the natural frequency. The natural frequency, we learned this one, K over M. As long as I have more than one stiffness, then this will be replaced by K equivalent over mass. So now K equivalent will be like this. K L cube plus 3EI over M L cube. Then this one will be replaced, W over G. So it will be K L cube plus 3EI over W over G L cube. If you simplify it further, you will get G K L cube plus 3EI over W L cube. So this is the second answer.